Ladies and gentlemen, let's start our student session of our workshop. The first pretender will be Gordey Smirnov. The topic is the effectiveness of genetic algorithms for optimizing the inventory of marketplaces. Gordey, you're welcome to share the screen.
Yes, thank you. Give me 1 minute, please.
We see your presentation.
Let's start. Good day, dear colleagues. Today I'm pleased to present our work on optimizing the distribution of goods across marketplace warehouses using hybrid genetic algorithm. This research lies at the intersection of logistics, applied artificial intelligence, and multi-objective optimization. First, I want to start by relevance. To describe my choice, you know that marketplaces are main part in our life. We use it at all, and now they have face serious challenges. Firstly, that warehouses are overloaded to the limit, making it difficult to accept new goods. Logistic costs continue to rise and reducing profitability. Sellers lose the ability to deliver goods to the necessary regions. And from next, I want to show you the picture. It's data by 3 days ago. I get this screen just 5 warehouses on Walbert's marketplaces, but they have more than 150, and situation is the same. Not available for deliver goods, and this is a big problem. And I want to give some algorithms that can help distribute more better that now. GA has 3 different points like statistic method, dynamic parameter change, and hybrid models. Hybrid models better because it use usual GA and special optimizing methods. From next, I wanna show you 3 more interesting algorithms. Like first of this, it's adaptive hybrid genetic algorithm with large neighborhood research. It combined genetic algorithms with adaptive large neighborhood, effectively solving transportation routing task with multiple attributes. Second, it's genetic algorithm with based random case and variable mutants, used based random case to solve transportation routing problems. And the last is hybrid genetic algorithm with mixed integer linear programming. For my project, I think I use one of these or our Bauman Yeva algorithm, like the same GA that can solve my transportation problem. And I want to describe the main logic, how it helps for sellers to solve their goods. For example, you have a manager who create distribution and who choose some special warehouses. Firstly, we find some goods like 100 units and give all information from our GI algorithm. They understand the relevant regions and give us advice to more relevation distribute. Next, of course, we need to preparing special data. It's a big work, and now we finish it. Firstly, we download all historical sales by regions, warehouse parameters like capacity, equipment, logistic, and some financial and economic indicators. Next, we demand modeling because we need to understand which region more relevant, like some guts, for example, it's ski or some clothes. On the next slide, I show you how it's distributed. For example, we have 3 different guts: lightweight jackets, sky suits, and down jacket. And we understand that in more resource cities like Krasnoyarsk, Kray, maybe Sochi, we need more sky suits because we have a sky and we have a special places for use. In cities with cold regions, we use more hot safety jackets like down jackets, and in Moscow and St. we use something like weight jackets. And it's important when sailors find a right place to distribute their guts, because if they, for example, send their light jackets from Krasnoyarsk, we use a lot of volume in warehouses and can't sell it because it's not relevant for this region. Now we finish algorithms to collect all of data and create some database. And the future research that we need to develop different algorithms to find relevant regions, to understand which of magazines more interesting and why, and use GA in our business processes and testing and integration. That's all, and I can ask on your questions.
Thank you very much. Alex, any questions? Nobody would ask a question. Okay, I ask a question. Could you specify your algorithm? A little bit more details.
More specify like process. For example, we can see that firstly, we think what is demand in region, then understand economy analysis like logistic cost, storage.
No, I mean optimization algorithm. For example, genetic algorithm, what kind of?
I think the first with a lot of neighbors, because we have a lot of different parameters that we need to understand, and it helped us to solve our problems, because another one means that we find like different type of transport. But the first of this and can show us to use some financial parameters, logistic parameters, and some special qualities of our guts, because of course we have some same gut, but with a little bit different on size or maybe print, and it's important.
Okay, thank you very much. I understand. And Alex, who would like to ask? No one. Okay. Gordey, thank you very much for your presentation and answering our question.
Thank you for listening, and thank you for your attention.
Okay, now our next presenter is Daniel Ageev. The topic recognition of technical drawing text using font unit TrOCR model.
Hello, colleagues. My colleague Nikita Smirnov are going to demonstrate and tell you about this topic now. Nikita,
Yeah.
I'll give you the word.
You can see your presentation. You can start.
Oh, I'm sorry. My microphone was muted. Hello, anyone, and thank you for joining us today. My name is Nikita Smirnov, and I'm here with my colleague Daniel Ageev. Together, we are excited to present our work on enhancing text recognition in technical documentation drawing using fine-tuned TR-OCR model. The modern development of optical character recognition (OCR) technologies make it possible to optimize the process and analyzing the preprocessing web processing text information. Text recognition on technical documentation drawing remains one of the topical tasks requiring a special approach. Drawing contains text elements of various formats and styles that need to be accurately interpreted and make to metadata support workflows. To improve the quality of text recognition on drawing, we are going to use TR-OCR model adapted to the specific of technical documentation. One of the key challenges in working with technical documentation drawing or TDDs is complexity of the text formats. This drawing often contains a mix of handwritten and typewritten text, making it difficult to traditional OCR system to interpret them consistently. Moreover, the styles of text in this drawing can vary widely, not just in font or size, but also in how they are aligning or embedding within the drawing. This inconsistently poses a major problem for recognition accuracy. On top of that, the text must often be mapped to associated metadata, which is critical for enabling seamless workflows in document management. When errors occur in this process, they can disrupt the entire pipelines, causing inefficiencies and inaccuracies in operation like quality controls or compliance check. Our study aims to tackle these specific challenges by developing a system that brings this gap, ensuring precise recognition of text and this alignment with metadata to meet the demands of these workflows. In traditional OCR approaches, models like CNN and RNN have delivered high accuracy, but the limitations lie in customization and scalability for niche tasks like technical documentation. Transformer-based models such as TR-OCR model representing a significant leap forward due to the ability to process information in parallel and adapt more easily to diverse scenarios. However, despite their potential, there's been limited research into applying this advanced model specifically to the unique challenges of technical documentation. Our methodologies involves, I'm sorry? We followed the key steps to make the model effectively. First, we collected technical drawing with various text styles and matched them with metadata. We also created a synthetic dataset to better accuracy. When we improved images through pre-processing using techniques like binarization, brightness adjustment, and data augmentation like resizing, rotation, noise, and color filters. This helped the model handle diverse inputs. So we pre-trained the TrOCR model for Russian text, improving speed and accuracy, and fine-tuned parameters. Finally, we evaluated performance using accuracy, completeness, and charter error rate with cross-validation for reliability. Preprocessing techniques playing a crucial role in pre-training the data for optimal model performance. For example, binarization was used to enhance contrast and eliminate unnecessary visual noise, brightness and contrast normalization helped standardize the images, ensuring consistent quality across diverse samples. Data augmentation was particularly impactful. Resizing allowed the model to adapt to varied text size, while rotation made robust and angled or skewed text. By applying Gaussian noise, simulating random lines, we ensured that the model could generalize effectively to the real-world scenarios with minimal errors. In our first experiments, we aimed to establish a baseline for the TrOCR model performance on technical documentation drawings. For this, the model was tested on a dataset of real-world samples, including both typewritten and handwritten text. Without any pre-training specific to the environment, the model achieved the accuracy of 93%. This initial performance set the stage to future improvement through targeted pre-training and augmentation. Next, we're focusing on the pre-training the TrOCR model using the dataset of 1050 real technical documentation drawing, carefully chosen to represent common elements found in CTDs. To enhance the model understanding, we incorporated a much larger dataset of 30,000 synthetic images and their corresponding labels. This pre-training specifically boosted the model recognition accuracy, achieving a remarkable 99.36% on the charter error rate metric. This improvement clearly demonstrates the value of domain-specific pre-training in overcoming the unique challenges presented by technical drawing. For future refines the model performance, we apply a variety data of data augmentation technique, each targeting specific challenges in technical documentation. Resize augmentation allows the model to better handle variation in text size, image rotation, which mimicked slight angles in text, and enhanced recognition across diverse orientation. Gaussian noise proved expectedly effective, achieving a CR metric of 0.008 by making the model resistant to distortions that mimic real-world conditions. Simulating random lines helps the model handle overlapping elements, and applying different color filter improved robustness to varied color schemes in technical drawings. This augmentation collectively allows the model to better adapt to visual distortions and achieve more consistent and accurate result, making it highly efficient for the real-world applications. The result of our study clearly demonstrates the effectiveness of TrOCR model when preprocessed and with a specialized dataset. By combining target pre-training with robust preprocessing technique, we specifically improved OCR accuracy for complex technical documentation drawing. The model excels in handling diverse text formats and styles, achieving high pressure even in challenging scenarios. However, one key limitation remains: the system's reliance on substantial computational power and high-performance hardware. Optimizing resource using a priority for future work, ensuring the system is more accessible and cost-effectiveness. Looking ahead, our goal is to integrate this high-accuracy text recognition system into exciting documentation management workflows. This will enable.
I'm sorry to interrupt you. You are out of time. We can read the last your expression. Thank you very much for your presentation.
Thank you for your attention.
Dear colleagues, our next presentation will be given by Nikita Bazin. The topic: research of the efficiency of self-adaptive genetic programming algorithm for regression problems. Nikita, you are welcome.
The presentation.
Daniel,
Daniel,
could you
can
stop your
you
presentation?
I think Nikita is screening. Nikita, can I close presentation?
Oh, I'm
Stop.
sorry.
Stop sharing screen,
Sorry.
please.
Sorry.
Okay, Nikita, you're welcome.
now you see?
Okay, we see your presentation.
Well, the theme of my work is presented on a slide, and let's begin with a goal and task which I set. The goal of the study is improving the efficiency of genetic programming by using a self-adaptive algorithm. After setting the goal, I can define the necessary tasks for myself. Tasks are the research of the self-adaptive algorithm, the analysis of the operators of genetic programming, setting the problems, the testing, and conclusions. Let's start with a short theory about the self-adaptive algorithm. Self-adaptive algorithm is an algorithm which sets parameters values in the main algorithm by using feedback during the work. It helps to avoid the manual parameters adjustments while solving any problem. Main methods which use in this work is choice based on probability, penalty, and social care. Probability choice is a number that means the probability of being chosen for the further creation or modification of an individual. These probabilities dynamically change during the work of the program. Probability can increase and decrease based on mean effectiveness of an operator. If any type of operator shows better results than other operators, then these other operators gain a penalty. Using this formula and the winner increase the probability of being chosen by summary of other penalty. The important part is social card, which means minimum of value of probably choice. And some words about the used main algorithm. Genetic programming is one of the heuristic and evolutionary algorithm. It is able to grow mathematical or logical functions to solve many problems. Because the algorithm is evolutionary, it uses the same operators as other algorithm. It is a selection, crossover, mutation, and survive crossover. In this algorithm, individuals are presented as functions, but there are many methods to represent functions. In this work, we have used a tree form. A tree has two types of nodes. Functional nodes consist of functions like a sine, cosinus, or summary, and especially of terminal nodes. Is that the includes outside inputs to the program. Here, the functions which are used in this work, it's 5 unary and 4 binary functions. Is these functions used in functional node and 2 in the terminal nodes. Also, constants in terminal nodes will be adjusted with differential evolution. Here are the types of operators which used in this work. Also, in brackets is starting probability choice. It's in selections, it's a proportional, ranked, tournament with the size 3, tournament with the size 5, and tournament with the size 10. Crossover is empty. Empty crossover returns one of the parents for further safe in the population. Standard crossover, 1-point crossover. In 1-point crossover, parent tree are stacked on top of each other, and one common node is selected. The nodes are then swapped, thus create a new individual. Also, it's uniform crossover. In mutation, sorry for it's tree mutation and standard in these formats. And the survive crossover are used best from individuals and offspring. Here are the settings which used in this research. The points are generated non-uniformly on this segment. Also, 80% is used for training and remaining 20% for error calculations. Penalty for the number of nodes is number 1 in this formula. Because the tree can grow infinitely, the number of created functions are also large. To avoid this, use a penalty for the number of nodes. In the trees will be used to reduce the freedom in growing function. On the slide show the function on which the algorithm was run and analyzed. Due to the fact that the algorithm is stochastic, it will be wrong to make only one run. With given settings, so 10 runs were made, and then the RMS median and RMS deviation are calculated. On the bottom of slide, the graph of median probabilities of different operations types are presented. As we can see on the graph, the tournament selections with size 10 is leading in the beginning of search progress. It may have increased the probability of empty crossover, because in the tournament selections
Даш,
from 20,
у меня конференция началась, я, по идее, в 20:10.
it may have increased the probability of empty crossover, because in the tournament selections from 20% of populations, the individual with the best fitness is chosen. Also, the empty crossover saves these individuals, and this causes the increase its effectiveness and its probability. Because of this, some of individuals did not change, so the algorithm did not work efficiently. In this experiment, median is 60, and RMS deviations is around to 10. although the error value is great, the function value is great too. Its value can reach 2000s. On the selections graph, we can see that no one is constant leader. All algorithms compete with each other, and this is a good sign because operator upgrades the fitness of individuals uniform, and no one is useless. In a crossover graph, standard crossover permanently lose the probability of being chosen, which means that it is useless for this scheme. However, the remaining operators try to improve fitness, but the empty crossover still often saved individuals show ineffective. On the last experiment, the Hermes median is 0.3 and Hermes deviation is 0.01. The Hermes deviation is very small and it says about identical solutions and that algorithm very often converges to one solution. As we can see, on all mutation operators, the dominant mutation is weak mutation. It shows that the algorithm often converges to some solution and cannot get out of it. The reason for the often convergence and the selections of empty crossover may be an incorrectly used fitness calculations functions or an incorrectly chose value for the tree complexity penalty. This all strongly limits the field of valid solutions. And the conclusions was algorithm was able to successfully complete the task as the complexity of the function increase. The algorithm requires a low value of complexity penalty in order to have more freedom in the way the function grows. In the selections and crossover operators, there was a constant struggle to increase the probability of selections. But in the mutation operator, there was a dominant in the form of weak mutations. And it's all I can answer to your questions.
Thank you very much for your presentation. Could you show your slide 13? Предыдущий. Here we can see algorithm functions and sum of two numbers. What does it mean?
Numbers in bottom?
Yeah.
Or
27 plus 29.
it's
Algorithm function, what does it mean?
it's a function which finite algorithm. It's two constants which summary. It's a
Instead
strange
of sum of 5 xy squared, cosine, and so on, just the horizontal line.
Can you, I don't catch your questions. Can you explain, please?
Алгоритм выдал функцию, которая является горизонтальной прямой, причем зависит
Yes.
от одной переменной. Там у вас сумма 5 переменных, косинус х в квадрате.
I think the reason of this because algorithm tried to improve the fitness, but fitness the most value is difficult and number of nodes, and algorithm don't want to search the more efficiently.
Okay,
Division.
in any case, your approximation of the function with 5 independent variables is the function of one variable.
Yes.
Do I understand right?
Yes. Algorithm don't use inputs. They use only constants.
And
Excuse me, can you turn on the 9 slide? Slide number 9, please.
9.
Look at error calculating. You tried to calculate mean squared error, yes?
Yes.
But why did you take the root of the sum when calculating the error, if in this case the evaluation of each solution was rounded?
Can you explain, please?
Ты при подсчете среднеквадратичного отклонения, по-моему, зря корень взял. Это угрубляет оценку каждого решения.
Okay, dear colleagues, unfortunately, we are out of time. That is why I have to stop discussion. Thank you very much for your presentation. And I announce the next presenter. It is Lev Kene with topic building a model for predicting fire dynamics in the Krasnoyarsk Kray.
Hello. Sorry. Can you see now?
Yes, now we can see. You can start.
Okay. Greetings to everyone. My name is Lev Kene. I'm a student from Siberian Federal University, and I made a research which called building a model for predicting fire dynamics in the Krasnoyarsk Kray. So let's start. The Krasnoyarsk Kray, with its waste forests and diverse ecosystems, faces a serious problem of forest fires, which poses a threat to both the environment and the population. The increase in the frequency and the intensity of fires in the region, partly due to climate change and anthropogenic activities, underscores the need to develop effective tools for monitoring and predicting the dynamics of fire disasters. The processing of data collected by the departmental services using modern data analysis methods, including machine learning, which will make it possible to predict the behavior of fires and assess the probability of their occurrence. So, in this study, we analyzed specific data on fires in the Krasnoyarsk Kray and then built a machine learning model to predict the dynamics of fires. The specifics of data analysis lie in the specifics of collecting data on emergency situations. The data is collected by departments of Ministry of Emergency Situations of Russia, and is recorded, first of all, in the electronic fire accounting card and its consequences. But the methods of collecting information about natural disasters may vary, despite the existing standard of data collecting. Due to differences in collecting methods, there may be data omissions, filling errors, and statistical outliers. All these features must be taken into account in the analysis. So, in the hands of researchers, there are data from open sources of the Ministry of Emergency Situations of Russia. They were divided in 11 files, and it is a data from for each year from 2010 and 2020 inclusive. There are 204 parameters in this set and 600,000 rows. However, not all factors are informative for conducting fire analysis. We chosen only 32 factors. And what is important, we don't have measurements of temperature and or fire propagation. So it's not possible to simulate the physical process of fire dynamics. So in this case, we will set the task of binary classification. We will build a ML model of predicting type of fire. The goal of building a ML model is to predict how complex a fire will be, simple or difficult. If duration of fire accident is more than 6 hours, it's a difficult fire. To start building a model, we need to pre-process data firstly. So, for processing, we used Microsoft Power BI. Here we joined all 11 files in one, selected the relevant parameters, selected data related for Krasnoyarsk Kray, because all data is about all fires in Russia. And we also should make a new column, such as target variable, type of fire, and handle errors, of course. The problems was joined with address factor because data vary a lot. So now we can make a preprocessing for a model, but firstly, let's look for some statistics. When we continue to work in Jupyter notebook environment and with the help of well-known libraries of Python, we conduct research. Need to admit that data is high quality, and due to a unified way of data collection, there is no manipulation in data, which means that the data is reliable. The key information from the descriptive statistics is presented on the slide. And here's the graphics. You may see a scatter matrix, info about gaps and box plots. Gaps was found in date of liquidation and locality, and also there are a lot of emissions. They are natural. So anyway, let's process data for a model a bit. Here I show the algorithm of my actions for the training set preprocessing. We got rid of outliers in numerical columns using the interquartile range. In normalization, we used the min-max scalar, and for balancing classes, we used random oversample. The following models were also studied in the work. It is logistic regression, key nearest neighbors, support vector machine, and stacking. Stacking model includes random forest model and support vectors machine classifier. Using the grid search, we searched for the best model and then built statistics on the predicted values in the test sample. So here you may see results of logistic regression in KNN, and accuracy of KNN is 96%. It's really pretty high. And here you may see results of SVM and stacking model. Accuracy of stacking model, there is a random forest and SVM is 97. It predicts better than KNN, but due to confusion matrix, it's wrong estimation. Since the forecast must be made at the stage of calling the file department, not all data is known initially. Key parameters can be known immediately when the file is reported. So we can make a management decision at the call stage, how many vehicles or departments we need to send to the site. So we have improved the program and added work with input data to it to make it possible. And as for results, the desired result is more than 80% accurate, and it is observed in 3 out of 4 models, which means that machine learning methods are great for working with fire data, but presumably neural networks will be somewhere more efficient than machine learning. They will learn faster and give a better result. And it is found that the most successful model is SVM, based on the ROC curve estimate. But speaking of accuracy, the accuracy of SVM is only 83%, while the best accuracy was achieved by KNN and stacking method. It is 96 and 97% respectively. Since there is an imbalance of classes in the test sample, and it is a real situation, it is simulated, it is more correct to rely on metrics such as F1's measure and accuracy. So that's all I wanted to say. Thank you for your attention.
Thank you very much. Dear colleagues, we have time to ask questions. Well, let me ask a question. You have chosen this 4, let me say, approaches for modeling. Why is this 4? Why not another one, or maybe 5th, 6th, and so on?
Can you explain on Russian? I haven't heard.
Окей. Вы выбрали 4 модели. Почему эти 4, а не другие какие-нибудь 6? Как выбирали?
I have chosen randomly, just what I was studied at courses I already finished. I thought, this is a popular models, and I should try
Okay,
them.
thank you. I understand that that's a question. Was it randomly or occasionally?
Maybe occasionally, because it is popular methods. They usually show them really in their
Okay.
best in
I understand.
any tasks.
Thank you very much. Well, thank you very much for your presentation and answering my questions.
Thank you.
Dear colleagues, now we have the next presenter. He is Maksim Koshin with the topic genetic programming application to build a decisive rule for the collective regression models.
Excuse me, do you hear me?
Yeah, and we can
Okay.
see presentation.
Excuse me, something
Oh.
is a little bit wrong with presentation. We see some closed area.
Excuse me. Give me 1 second, please. Bum, 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 bum. Do you see the presentation?
Да, но оно почему-то перекрывается какими-то черными
Okay.
линиями.
I think this is Zoom windows. Try to minimize Zoom windows on the right and on the bottom. Снизу и справа зумовские окошко уберите.
Может, на F5 нажать?
Сейчас, секундочку, пробую. Теперь все хорошо?
Уже лучше. Okay, you may start.
Good afternoon. The topic of my report is devoted to the genetic programming application to build a decisive rule for the regression models collective. Regression is a statistical technique used to analyze relationships between variables. The main purpose of regression to establish relationship between one dependent variable and one or more independent variables. For various reasons, regression models can be inaccurate, in which case multiple regression models are used for the same data to compare which one can be used. But there is an approach. The conclusion is to combine existing models to obtain a more accurate result. This approach is called ensemble learning. There are several approaches to ensemble learning, but in general, conceptually, they all look like something this. Before introducing one approach to ensemble learning, let me remind you that there's a type of evolutionary algorithm called genetic programming. In genetic programming, an individual is represented as a tree in which there is a terminal set, variables and constants, and functional set, possible operations that can be performed on elements of the terminal set. Just like in other evolutionary algorithms, genetic programming provides crossover, mutation, and selection operators. There's also an operator-by-operator self-configuration option. This method also has a built-in genetic algorithm, the main task of which is to correct the constants in the function so that the error is reduced. That is, for each option of crossing, selection, and mutation, there are options that are used with a certain probability. And as the algorithm operates, the probabilities change in favor of the most effective ones. The process of selection, crossing, and mutation is repeated over several generations until an optimal or near optimal solution to the problem is found. Let's consider the approach to ensembles from the point of view of genetic programming. Let there be data on which you need to build a regression. Regression is built using three methods: key nearest neighbors, linear regression, and neural network with function of activation ReLU, and two layers of 10 neurons. The outputs of these models are combined using genetic programming so that the mean squared error is minimized. As a result, we obtain a function that combines all three model outputs according to the MSE criterion. On the slide, you can see the function being tested. These are two linear functions and two complex non-linear functions with another dimensions. The initial parameters of genetic programming are as follows. The number of generation is 30, population size is 35, limit of operator selection probability values is 0.1, and tree depth is 5. This slide presents the results of testing the presented approach. Considering the first function, it is clear that there's no need to use an integrated approach, since for data that is linearly distributed, linear regression is sufficient. There are no statistically significant differences between the outputs, which means the Wilcoxon test is satisfied. But when considering subsequent functions, it is seen that as the data becomes more complex, individual models perform worse than combining them through ensembles. Here you can see an example of how the algorithm works using the first test function as an example. We get the concatenation of three methods that use the special function that give us mean squared error need minimized. Yeah, here you can see visualization of true function and ensemble output. Oh. Results can be said as follows. Constructing ensembles using genetic programming gave better results compared to each method separately. This approach allows to adjust the final solution and combine the outputs of existing models. And from decision-making point of view, this approach allows to select the best model from the represented ones if the other models are not fit in terms of the considering criterion. And that's all. Thank you for your attention. I'm waiting for your questions.
Thank you very much for presentation. Please, colleagues, any question? No questions at all. Okay, let me ask the same question. Why these three approaches are you trying to combine? Why not others?
Why exactly that's three?
Yes. And why three? Not two, not five, but three. And exactly
I could use
three.
more than three methods, but I make a decision to use exactly three methods. And why KNN, linear regression, and neural net? because linear regression is good approach to get regression of linear distributed data, and other methods we can use when we consider the nonlinear distributed data. And I wanted to watch how can we concatenate this. Exactly.
Yeah, but if you use one of these methods and spend all computational efforts that you have spent for ensemble, maybe it would be much more precise. Is that now and ensemble also?
I don't know. I just wanted go that way.
Yeah, because the question is why we need to sophisticate something instead of make something easier but long enough. With the same computing time, for example, neural networks, why not? Okay, you did not pay attention. Yeah. Okay, thank you very much for your presentation and answering my question. And now we are ready to listen the next presenters, Ivan Malashin, enhancing defect prediction in SLM processes.
Hello, do you hear me?
Yeah, and we see your presentation.
Okay, thank you. Yes, today my presentation is for enhancing defect prediction in SLM processes. Now, what SLM is a selective laser melting is used for layer by layer manufacturing of parts from powdered materials. The laser beam locally melts the powder particles, forming a solid layer, after which the process is repeated until the final product is created. So here we see a laser, and this part is zoomed, and we can see like powder is melted. So this and creating a new detail. But this process is during this process defects can occur. So the aim of the study is to determine such defects. One of we suggest an approach where video recordings of the SLM process. So here was camera and video recording of such melting pools, like here. It's 120 pixels. Such pixels are monochrome, so it's not it's like matrix. This matrix make like a vector, and this vector is dimension reduction from 120 is 40,400 is dimension reduction to 3 components. Of 3 at this I make it for a SLM process for random 5,000 frames, because it was like large video recordings of and this step was to reduce computational complexity. So next step was to apply clustering analysis to cluster the reduced representation of frames into in patterns. So that's why we have like these cluster maps with patterns, but these clusters has been discussed by experts in the field. So, for example, this one was like normal clusters. some clusters was overheating, and if overheating, it means defect. So we decided to make 20 clusters as optimum. So after such clusters aim to determine places on the scan path where defect occurs, and that helped to create 3D representation of the defects in detail. And in such case, we can see that each 5 layer was concentration or deconcentration of defects. So this could be occur due to maybe errors in scanning parameters on each layer. So hence it would be beneficial if change parameters during 5-layer printing, and it will help to avoid such defects. Yes, so yeah, that's all. Thank you. Yes. Yeah. Yeah.
Did you finish?
Yes. Yeah.
Okay, thank you very much for your
Thank you too.
presentation. Please, colleagues, any questions?
What groups you're in slide groups point in the site? Do you make
Huh?
Nikolay, we did not understand.
I don't understand.
Oh yeah, but
here. But here.
Николай, говорите громче, скажите по-русски, может, лучше поймем.
Да, просто плохо слышно.
Of groups in groups point in the in slide this end slide.
This slide.
Yeah, red points groups. What is it?
Defects. It's defects. Yes. On if 5-layer such, it's about some kind of millimeters, like one layer. For example, this one is about less than 2 or 3 millimeters. This one, yeah. So it's very thin, very small area of defects, very small. So, but it could influence on the overall quality of material of this detail.
Well, any more question? Okay, no questions. Thank you very much for your presentation and answering our questions.
Okay, thank you too. Okay.
Ladies and gentlemen, our next presenter is Nikolay Podanyov with the presentation Cooperative Coevolution of Differential Evolution Algorithms for Solving Mixed Optimization Problems. Okay, Nikolay, we can see presentation. Say something. Nikolay, we cannot hear you.
You see my presentation?
The sound is bad. Could you speak more loudly?
You see for me?
Yes, we see presentation and we can hear you. Just speak louder.
Okay. How am I say? Normal? Good?
Okay.
Okay.
Let's start presentation.
Hello. I'm studying in university, Regression studied Siberian State University of Science and Technology. My advance in slide. Go. The work is developed to the adaptation of the difference evolution algorithm for problem with mixed variables in terms of algorithm self-configuration and cooperation with another algorithm. The adaptation of the different evolution algorithm boils down to algorithm ability to work with categorical variables based on random search. The paper presents the adaptation methods of calculate a new value of a categorical variables in slide. The self-configurable genetic algorithm is a test result algorithm, the basis for comprehending all the algorithms. The algorithm has 36 different configurations related to the choice of the type of selection, crossing, and mutation. Self-configuration adaptate algorithm of different evolution. This algorithm has 18 algorithm configuration relate to the choice of the improved individual, the choice of the degree of vector change, and the method of calculate the new parameter. The cooperation of the algorithm took place crossing to the shame with a 50-50 split of the sample with the separate of individuals every generation. The algorithm of difference evolution with a numerical representation of an individual has performed best in problems with numerical analysis. The adaptation of the algorithm is comparable to the genetic algorithm. For problems with mixed variables, the different evolution algorithm is compared to the genetic algorithm. The interaction of the algorithm turned out to be the best, provided that the restriction on calculating the objective function is the same as for the algorithms individually. The best is that the algorithm has the high head reliability and convergence rate. The proposed adaptation of the differential evolution algorithm works comparability with the genetic algorithm. In problem with mixed variables, the interaction algorithm shows better results than the algorithm individually. But based on this, setting up self-configuration in cooperation and as gain task. Then for my presentation, do you make questions?
Thank you very much for your presentation. Okay, dear colleagues, you have time to ask questions.
Okay, I have a question about test problems. Where did you take test problems? Why?
He see in slide this problem. One more. This problem this.
Yes, where did you take it from? From which source?
This I use standard problem, and how this my problem I generate I generate it. I'm generate it in my idea.
Myself.
myself.
Okay, okay, I understand. Thank you.
Any other questions? No questions. Okay, thank you very much again for presentation. And our next presenter is Yulia Cheprasova with the topic research of approaches to fitness calculation and mutation operator implementation in genetic programming. You are welcome.
Hello, do you hear me?
We can hear you. We see your presentation. You are welcome to talk.
Thank you. The topic of my report is research of approaches to fitness calculation and mutation operator implementation in genetic programming. The study addresses the problem of symbolic regression, which aims to derive a mathematical equation that best describes the given data. In this context, solutions are presented as equations stored in the computer's memory in the form of trees. For the experiments, an open dataset from the Kaggle platform was used, providing information about housing prices in Boston. The dataset consists of 506 observations and 13 features. The aim of the research is a comparison of approaches to mutation operator and fitness calculation implementation. To achieve the goal, the following tasks were set. A common method for calculating fitness is by using a formula. In this case, a formula is designed to account for all necessary criteria for evaluating an individual. In this study, the following formula was used. Variables represent features from the dataset. However, this approach has certain drawbacks. For instance, if the MSE value is high, the individual receives low fitness value and is unlikely to enter the next generation. Therefore, an alternative fitness calculation method using ranks was proposed. This method involves sorting individuals based on each of the previously mentioned criteria and assigning corresponding ranks. These ranks are then multiplied by certain coefficients and summed up to obtain the fitness value for each individual. The program with different implementation was run 24 times. In 16 cases, the rank-based fitness calculation method produced more accurate results. For better visualization, the mean and median MSE values were calculated, and to confirm their significance in the differences in the obtained MSE values, the Mann-Whitney test was performed. The test results indicated that the samples are not homogeneous, as evidenced by a low p-value. In genetic programming, one-point mutation involves replacing one randomly selected node of a tree with another generated randomly. However, an important consideration is how to randomly select the node where the mutation occurs. The initial solution involved using a predefined constant p, representing the probability of mutation for each node. The tree is traversed in post order. At each step, the algorithm generates a random number between 0 and 1. If the number is less than p, the node mutates, and the algorithm stops processing the current tree and moves on to the next. However, the study revealed a significant drawback of this approach. As the number of nodes in a tree increases, the likelihood of mutating the root decreases drastically. This is because the root is the last node considered during traversal. Therefore, it was decided to try a different implementation of the mutation operator. In the second approach, each node is assigned an equal probability of mutation. This is achieved by first counting the total number of nodes in the tree and then randomly selecting one for mutation. This method ensures that every tree undergoes mutation, thereby maintaining diversity within the population of solutions. This slide represents the results, demonstrating that in 23 out of 24 cases, the MSE value is lower when using the second mutation operator implementation. Additionally, the Mann-Whitney test confirms that the differences between the samples are statistically significant. The study resulted in an algorithm that produces more accurate solutions. In the future, the developed genetic programming algorithm is planned to be used to derive a formula for adjusting the learning rate of a neural network based on the epoch number. Thank you for your attention. I'm waiting for your questions.
Thank you very much for your presentation. Dear colleagues, any questions? We have time. No questions at all. Okay. As a question, as usually I ask, why you investigate this only short list of possibilities? Why not wider? Why not another?
Can you repeat, please?
Почему вы исследовали именно эти варианты? Почему ровно столько? Почему не больше? Почему не другие?
There's just a heuristic.
Sorry?
It's heuristic. I tried with different parameters and implementations. That's the best.
Yeah, but there are much more heuristics here, not this one. How did you choose exactly this among many?
I'm sorry, I don't understand in English.
Как вы выбирали именно эти эвристики из многих существующих?
Я советовалась со своим научным руководителем.
Понятно. То есть это вопрос к нему, почему он так сказал, да? Окей.
Ну, это так ощущается.
Thank you very much. Dear colleagues, any questions, please?